Okay. It's 2:35, so I'm gonna get started. I try to get started exactly on time. I was here very early because I'm still not sure how I got here, to be honest. I just poked around low building until I found it. So yeah, this is COMP2401 Section D. I'm Daryl Hill, the instructor. This is a course in systems programming, Introduction to Systems Programming. There are 3 other sections, and we are separate from them. So I'm running it a little bit differently than Connor is. I like what Connor's doing, but for whatever reason, I decided to go with a more conservative, traditional approach of like 5 assignments and 2 quizzes and a final. And he's doing some experiment, which I hope works out because, I think maybe what he's trying to do might be the future of how this course is run. But for me, this is what we're doing. So the material is all the same, and hopefully, the experience is all the same, and what you learn should all be the same. But like the way you're going to be assessed in this class is closer to traditionally how it's been done in the past. Connor and his 3 sections will be trying something a little bit different. One thing to point out, if you have an old version of the course outline, I've just moved offices. So now I'm in, my office number is HP 5167, not the old one any longer, although my name is still on the old door. When office hours start up, that will be where you can find me. So let's talk a little bit about the delivery. Can everybody see this is okay? Is the font size good? Just let me know. Also, let me know about sounds. And this might be, it doesn't maybe seem very small, but it's probably the smallest course I've taught in 2 or 3 years. Yeah, it's kind of intimate here. So lectures are actually live and in person, but as you may notice, I'm recording them over Zoom. And there's a couple of reasons for that. I like watching recorded lectures when I want to learn something, and I maybe already know some of it. And I don't want to waste my time like rewatching the whole thing. I can just, watch it on double speed and then slow down when I need to. So it gives you an additional resource for the classes. But also, of course, if you're sick, you should stay home. And if you're staying home, you might miss a lecture through no fault of your own. So if so, you can still watch it over Zoom or watch the video at a later time. But this is an in-class, in-person, because I want you guys here to write the midterm or the 2 midterms, the 2 tests, which might be short. And I don't know if you've ever written a midterm on those little tables, but it's going to be a little interesting. We've done it before. It is all doable, but it's a bit of a pain. Tutorial sessions, which start next week. Okay, attendance is not mandatory. They're a resource for you. I hope you use them, and I hope you find them useful. We're going to try and make them useful. That's the whole idea, is that we want you to find value in it. I don't really want to take attendance and force people to show up for a mark. But even though I think that's maybe a good idea, because the more you show up to these things, even, if you think you already have a handle on the material and you don't really want to, well, there are opportunities to connect with your peers and discuss things with your peers. There are opportunities to connect with your TAs, and it just makes the whole experience of learning a lot better, in my opinion. So the attendance is not mandatory, but you can go there and simply work. You don't even have to ask the TA a question. You can go there, do your work, and if you have a question during the course of your work, you can ask them. Or you can ask your peers. So yeah, discussing solutions is perfectly acceptable. Okay, and in fact, like in the real world, nobody programs isolated alone in their basement, right? In the real world, everybody talks through problems. So you guys want to do that, that's great, and I encourage that. In addition to, so that's the tutorial sessions. I really should name these things differently, not to be confused with the tutorials themselves. So these are weekly programming assignments. These are on Brightspace. I'll show you in a second what they look like. I have to do a little bit of editing before I release the first one. But yeah, so there are weekly programming assignments with marks that are called tutorials, not to be confused with the tutorial sessions, which is a physical location where you show up and ask the TA questions or do your work or whatever. Assignments will be programmed using C. right? So this is a systems programming class, and C is really the de facto systems programming language. And so we will be using it C, and you'll upload it to Gradescope or Brightspace, most likely Brightspace. We'll talk about maybe what's going to happen. Maybe I'll write some auto grader code if I have some time, and then you might upload to Gradescope. TA office hours will be posted on Brightspace once finalized. I think they are finalized. I just have to post them. In addition to office hours and all those things, there's going to be a forum on Brightspace. That's sort of the official online channel between you and the TAs, okay? And the reason, I don't know how many people like Discord. Some people, yeah. I think it's great. I think it's great. I don't want to officially run a Discord though, for a few reasons. If I run a Discord, I have to police it, right? Because I can't have people saying inappropriate things or getting into arguments. And then I'm responsible for that. And I don't think it's the best way for me to interact with you guys. First of all, like come to my office. Even I'm gonna post office hours, but anytime. You can drop in for 5-10 minutes outside of my office hours. I don't mind. I much prefer that. Discord is just a little chatty, right? Like, and that's great for you guys. It's great that you're connecting. It's not so great for me when I'm looking for questions to answer. That's all. So that's the only reason why I kind of leave Discord in your hands. If some student wants to make a Discord server, I'm happy to post the link, but it is an unofficial Discord server. Okay. Officially, Brightspace will be where you ask questions. And of course, on Brightspace, there's a lot more traceability. It's got your name and student number. And if somebody says something inappropriate, it's really easy to prove it was you. All right. 2 midterms will be in person. I did 2 because I don't know. I usually do 1, but 2 takes a little bit of the pressure off, right? And because I'm doing 2, they might be like half lectures. So they might be 45 minutes, and then we continue with the lecture after that, but we'll see. I haven't quite decided. The final exam will be in person, scheduled by the registrar. Okay, so this is a systems level programming and fundamental. It's mostly going to be programming in C. C is quite different from things like Python, like way different, right? Yeah. I haven't quite decided that. So probably a lot of short answer, especially the first one, because the first one, there'll be some programming, but there'll also be a lot of like data representation and things like that, which aren't really directly programming. So probably short answer. The final might be more multiple choice. Yeah. Yeah, so this is C is sort of different, way different than Python, right? Python you can kind of get away with. You do things you kind of shouldn't, and it still works. Python's like magic. It's very expressive also, whereas C, you're kind of bumping into the hardware at all times. And when I say hardware, mostly I mean memory, but there's other things like system calls and threads and things like that. You're not hidden from these things anymore. So you should have a minimum grade of C- in 1406, and also you're going to need a C- in this class to move on to COMP2404 if you're in computer science, right? So keep that in mind. Anything less than a C-, is, a D is still a pass, but it's not going to move you forward in your degree. The reference textbook. So I posted a bunch of notes. They're written by Mark Lantier based on some previous notes by Christine and Doran. So they're great. I don't know, Mark Lantier's notes are pretty fantastic. And I made a bunch of slides, but they're based on these notes. The examples come from Mark's examples. So the textbook, or the notes that are posted on Brightspace are an excellent resource. There is a laptop requirement. If you don't know what the laptop requirements are, please click these links. All right. Final grades are determined using this scheme. Again, there's nothing really special about it except for maybe the assignments part here, but tutorials, best 8 out of 10, 1.25% each. For a total of 10%, what I like to do is like, I know what happens, right? So there's inevitably an assignment where you don't do as well as you wanted to, or maybe you missed some tutorials, or your mark is not quite where you want it to be. So what I often do is, it's the best 8 out of 10, but if you do all 10, I might put in some bonus marks, right? So that sort of your mark, if you're on an edge of a letter grade, well, if you do those extra tutorials, then you can boost yourself up. And then so all of this stuff is in your control, rather than you're asking me to bump your grade up. So, if you think you're worried about, I don't know, if you're going to slack off at some point on the assignments, maybe do all the tutorials, and that can help you out. The assignments, it's a bit of a different structure from probably a lot of people, but I take the 4 highest, those are worth 9%, and the lowest is worth 4%. And the reason I do that is because I like the idea of dropping an assignment because, yeah, again, life happens and you don't always put your best foot forward. But in practice, that just means that everybody does 4 assignments, and then you're missing out on 20% of the course material, which I think is kind of bananas. So even if you do poorly on an assignment, I want you to try it and learn something. Even if you don't learn anything or everything, at least you have something, you get something from it. And then it won't count as much towards your final grade, and you don't do as much damage to your GPA. 2 midterms worth 10% each, and a final exam worth 30. So 50% assignments, 50% fine, or tests. Right. Questions so far? Yep. I'm sorry? Oh, you're asking if there's group work? That's a very good question. I know Connor does it's going to be most likely your own work. So officially right now, everything's your own work. Maybe the tutorials you can collaborate, but I'm going to point out a few things about that. Because in essence, I don't mind when you do these things as long as it's in the spirit of learning and not really the spirit of like, oh, I don't really want to do this tutorial, so I'm just going to take all your answers. So we're trying to penalize that part of it, but kind of collaborating, I don't really mind. As long as you're learning the material, that's great. But yeah, so we'll talk a little bit more about that. Midterms will be held during class on the dates indicated. The tutorials are all mandatory. No exemptions will be made for missed tutorials. Assignments are also mandatory. Late assignments are never accepted. Okay, so when I used to teach, when I first started and I was teaching first year, I made the assignments due on Friday, and then the late due date was Sunday, and every day that you were late, you lose 20%, and then on Monday it was 0. And technically that's an extension, but then when I got the second year, I'm like, well, you guys, I'm putting the onus on you now, right? So instead of deducting 20%, nobody starts marking till Monday anyway. So instead of deducting 20%, I don't deduct a thing. They're just due on Sunday. So now you have to put that extra pressure on yourself to try and start early and not be late, okay? Because basically it's the same thing, but now I'm not taking away any marks. So that's sort of my philosophy there. That being said, never accepted is a strong word. If you don't submit your assignment on time because you made some mistake, like you submitted an empty folder, and whether or not these things actually happen, I don't know. I've had these stories though, but the key is that if it happens and you miss the deadline, email me right away with your code. Okay, so zip up your stuff, email it to me and say, I accidentally submitted an empty folder. Here's my actual work. And if it's relatively close to the deadline, I'll attach it on Brightspace for to be marked. Okay, I don't mind doing that. But don't email me without attaching your code and say, what do I do? And then I email you back and say, well, send me your code right away. And then a day later, I get your code. And I'm like, oh, well, I can't do that. That's too late. Right? So the TAs have already got their marking assignments. And the idea is that we have these deadlines so the TAs can organize their time as well. Mistakes happen, but just fix it as soon as possible. The timing is everything. All right. It's your responsibility to ensure that all your marks posted are correct within 1 week of the date the marks were released, right? It's just because otherwise everybody tries to argue everything at the end of the semester. So we release the marks, just make sure that double check that everything looks good, and then no collaborating allowed on the tests. Obviously, collaborating in assignments and tutorials is acceptable, only at the level of discussion. But that means that, I guess, kind of this means you can sit with your friends, with your, both each have your own laptop, doing the tutorial and discussing. Like, that's kind of okay as long as you're learning. You know, sort of, you kind of have to take responsibility for yourself a little bit, right? The worst thing that you can have, that can happen, is you graduate with a degree in computer science and you don't know how to program. Like, wow, that's really damaging to the start of your life, because now you can't get a job and you've spent tens of thousands of dollars. You know, we don't try to do this because it's an exclusive club and it's so great. We do this, like, all of these restrictions are sort of to save you guys from yourselves. I know how it is. If you get lazy and you have an easy out, you take it. But we want you to get out of here having learned something for your own good, right? Yeah. Uh, for the tests, certainly. For the assignments, possibly. It depends on the marking scheme. I try to make everything as clear as possible, right? So if you do have an argument, whether or not I give you the solutions, you can really just say, like, because you'll get a bunch of marks for it working, which it's pretty obvious it works or it doesn't. And then you'll get some other marks. Maybe I tell you don't use global variables. And then if you use a global variable, you'll lose a mark. So all this stuff, I try to make it very obvious. If you're going to argue your mark, it should be very clear that, you know. Yep. Other questions? Yep. No, not attendance. Just completing it. Yeah, yeah. They're both called tutorials, but I really should rename one of them because they're not really connected. Other questions? All right. AI. So who here has used ChatGPT? Obviously, everybody, right? Have you asked it to program something for you? Yeah, of course. Sure. So what was pretty good at some stuff, eh? So yeah, this is sort of a big problem. Like, you guys are kind of you know, the first generation that's going through this, because when I learned from a textbook. There's none of this. And it's also, I'm going to say officially, you're not allowed to use it on assignments. Officially. Now, that being said, there's no way I can prove whether you did or you didn't. I just can't. There's no way to tell, unless your assignment has the words, this is a large language model in it. And then in that case, that's on you. And I'm going to send you to the dean. But otherwise, I don't know. There's no way to prove it. I can suspect, but I can't prove it. And we have to be able to prove it. So officially, just don't get in my face. You know, don't be super obvious about all this stuff. That being said, like, the takeaway from this course is, if you think you're going to learn how to use a large language model, well, spoiler alert, it's going to take about a week for you to learn that. But it's going to take you a semester to learn C, right? So hopefully you should dedicate yourself to actually learning some C. And we will talk about how large language models work and what they're good at and what they're not. The real problem is that they're kind of pretty good at university level assignments. I mean, they're really good. I find there are ways to, like, sort of throw them off by just making things a little bit kind of weird and strange and, like, off pattern a little bit. And that can fool them a little bit, but, like, if you ask it to make a linked list, it's going to make a perfect linked list for you, right? In any language, because there are a million examples of that on the internet, and they're trained on the internet. So it's very good at that stuff. And yeah, so you guys are kind of the first generation that's going to be learning programming while you're having this super tool that can really kind of solve all these problems that you're supposed to be kind of struggling through. So yeah, and then hopefully some of you become instructors, and then when you become instructors or professors, you can help us figure out how to teach this correctly. and maybe how to change things. I think actually Connor's got a good idea in terms of how to address it. But yeah. But that being said, don't shoot yourself in the foot, right? Try and learn something. Because the problem is it's good at university level stuff, but when you get out into the real world, now your boss or is going to ask you, or maybe you're working for yourself, and you're going to be trying to create something new, right? Because new things are kind of more valuable than things that have already been created. Programs are fungible. If I have one, I can just make a copy. But making a new program that no one else made, that's worth something. And large language models can't really do that very well. You have to know how to program to do that, even if you're using a large language model, which you probably will be. Okay, so it is still important to learn the fundamentals of programming because, large language models just repeat stuff they've already seen. With some, they do some interpolation. We're going to talk a little bit about that, but it's still, you're still going to need skill to figure out when it's lying to you and when it's doing just bizarre things, right? And yeah, anyway, questions? Hopefully that's clear. So yeah, officially, you're not allowed to use this on assignments. Unofficially, I cannot prove anything unless you make it super obvious. Don't make it super obvious, but do try and learn something, right? All right. Also, the tests, maybe not the first one. The first one, we do some, data representation and things like that. But then after the second one, certainly there'll be programming on it. And you won't have any large language models then. And then all of the tests are worth 50%. So, of course, in terms of academic integrity, don't post to like JAG, Course Hero, all those cheating websites. If you do that and you get caught, that's obviously a violation. Yeah, important considerations. Yeah, technical problems don't exempt you from late assignments, right? So I give you the assignment with plenty of time to do it. You should start early, update frequently, and submit frequently. And also, if you don't get it done, just submit what you have, all right? And get the part marks. It happens. It happens all the time. I mean, I wasn't always a perfect student either, so. For the midterms, if you're ill or something else comes up, just a self-declaration form, all right? There's a link here, or you can Google it, and that's it, all right? If you have some trouble, I sympathize a lot, but you don't need to share the details with me. I mean, you can if you want, but you don't have to. That's private stuff sometimes, and it's just, I trust that you're adults and you can determine if you're too sick to come in, or if there's an emergency with your family or whatever. So just give me a self-declaration form. Email it to me, please. And I may not always answer right away because around the midterm time, I get tons of these. But if you are worried that I didn't receive it, well, first of all, don't worry, I received it. Unless you got like I could not deliver this message, I got it. But if you're worried, you can always send a follow-up email and I will answer that. Okay. Please, expect to spend a significant amount of time working on this. If you're taking full-time courses, you should be kind of doing full-time job hours. So that means, 9 to 12 hours per week in this course, depending on which week. Also, the emails, right? I should get better organized with my emails, and I do answer or attempt to answer all of them unless it's something obvious from the course outline. Sometimes I won't answer that, depending on if I have time, right? It's just low on the priority list. But other than that, if it's important, I always try to answer. Sometimes it gets buried. So if you don't receive a reply in 3 days, just email me again, or even sooner than that. All these materials are intellectual property of the instructor. Okay, so technically I don't care after the semester is done if you post the assignments. Don't post the tutorials. Those are not mine. Mark made those. The notes belong to Mark, right? So they're not necessarily the intellectual property of this instructor, but they're other instructors, so you'd have to get their permission to post things like that. But the assignments, once we're done, you can do whatever you like with them. There are computer labs if your computer breaks for whatever reason. I don't know all the details, but there's links here. All right. So finally, the last part of this, the undergraduate academic advisor and other resources in general, but in particular, the undergraduate advisor. If you're not sure what you're doing, if you're not sure, if you failed the class and maybe, okay, what does that mean now? What do I have to do? Or you didn't get the mark you expected. These people are great. They're there to help you, right? There's a lot of people that work at Carleton that are here to help you, make them earn their paychecks, right? So go see these people. The undergraduate advisors are great, but in addition to that, uh, sometimes life happens and things don't go your way, and you feel maybe anxiety or pressure or defeated. Don't feel that way alone. Come talk to somebody. If you need to be directed to somebody to talk to, you can ask me. I will find out. I have to find, I don't know, I moved offices, so I lost a bunch of stuff, but there was a sheet of all kinds of contacts. And if I can't find that sheet, I can certainly find somebody who can find that sheet. So yeah. Yeah, there's lots of resources here. Make use of them. This is the sort of tentative calendar. So the whole, the rules, I guess, this semester are that I have to give you a bunch of due dates, and if I change them, they have to be in your favor, which means the dates will move back. Okay, so I can't move these dates up, but I can push them back, which I might end up doing, particularly with assignment 3 here. I put it here just for safekeeping. I like the idea of it being the week after, but I wasn't completely decided, so I put it on the earlier date. So just, I will send out a notification if anything changes. Yeah, the midterms a little bit. Typically midterms are here, but since we're having 2, I'm going to do it a week earlier. So that kind of maybe takes a little bit of pressure off you guys as well, in terms of having all your midterms in the same week. But yeah, okay. Other questions or any questions? All right, so assignment 1 should be released hopefully this week, if not Monday. It really is complete, but I have to make the marking scheme. And so now I have to decide. I really like auto graders in computer science because now you're writing code that talks to other code, which is basically most of what your career is going to be. There's only very few people who write code that talks to people. And it's a very consistent marking, and you get your mark back right away. You can, and it gives you a little bit of feedback where your errors might be, but it takes a lot of effort on my part. And I think I'm going to have time, but maybe not for every assignment. So we'll see. The assignment's ready to go, but all right. So that's sort of introduction, course outline stuff. Any questions? Yeah. Has it not? Did you click the link? I think I didn't download the roster yet. So, okay, yeah, I'm going to do that. I should have brought my notebook, but yeah, I'll probably remember to do that. Yeah.
That's about this house. Apparently, we're going to PM for assignment and whatever.
Yeah.
Download the PM, but I'm having trouble running it, mainly because I don't know what system I'm supposed to run the image on. So if you could be more clear with instructions about what the specific software to use and
Virtual, yeah. Okay, I will go through an example. But if I don't address, first of all, you can, yeah, feel free to interrupt me during the example, but also like this is a great thing to go to the tutorials for, right? So the TAs can actually sit down and take the time to help you properly if you're having, every once in a while, somebody has a weird issue, right? So. The first question of the first tutorial is install the VM, the virtual machine, yeah. Yeah, in that, might as well, who has a Mac with an M1 or M2? Right, a bunch of you, eh? So you guys might be, so VirtualBox doesn't work on your machine, is that correct? Yeah. So you guys might have to, you guys will probably be using OpenStack. Now, that being said, there are a lot of, well, we'll talk about that. There are a lot of solutions that do work that are not, maybe not quite correct, but they're good enough to get you, as long as you test it on something when you're done, right? Because you can install, we're going to use the GCC compiler, and you can install that on a Mac or Windows. I think it might even be pre-installed on a Mac. There are a couple of minor differences. They're supposed to be the same, but they're not quite. So you just got to be careful, but you'll still, you'll still be able to learn. And yeah, so we will get to the virtual machine today. Actually, I'll show you a little bit about it. But first, oh yeah, so the quote of the day. I found a series of quotes. So we don't talk a lot about, or maybe they do, I don't know, but I don't remember hearing a lot about the history of computer science, and it's actually really fascinating. And so just part of that is, for me, to find interesting people and their interesting quotes. Vaughn Vernon, I don't even know who half these people are, but they said some cool things, I think. Developers are too wrapped up with technology and trying to solve problems using technology rather than careful thought and design. That's certainly true. When you get out in the working world, everybody seems to, or at least there are some places that will chase a new fad. This is sort of relevant because C is as old a language as you're likely to see, right? And it's barely changed in all that time. And the reason why it's barely changed is because it works so well at what it does, which is basically works at a really low level. So what is systems programming? Low level programming. So close to the metal is another sort of phrase we use to describe it. It means you're going to be bumping into the hardware in some sense, right? You're going to be faced with the limitations of your CPU and your RAM and all of that, and working closely with your operating system. And so yeah, fewer abstractions. So abstractions are wonderful. They're the reason why we don't write assembly code anymore, but they're like sometimes they come bundled with like, it's a what do you call it? A Faustian bargain, right? So you get this beautiful, shiny language that works really well, but it runs really slow, right? Like Python. Python's a great scripting language, and I love it. I would not want to have it run for a million people at the same time because it's going to be terribly slow. But it'll, run through a spreadsheet and do some fancy things with that. So what you've been doing up till now is, called applications programming. It's not that there's a clear line between what's an application and a systems program. And technically, we're going to be writing applications in a systems language, C. But that being said, sort of the idea is that applications programming are some service for the user, and systems programming is services for other software. That's the high level idea. It's not quite what we're doing, but it's close enough. We're learning things that would let you be a systems programmer. So application programming programs are a video game, word processor, Android app, or iPhone app, or whatever, websites, social media, all of those things. Systems programming, operating systems, right? So now you are providing services for applications, right? So we have our hardware here, and then we have our operating system and or system software, and then we, run a web browser on top of that runs TikTok or whatever. Other examples of systems programming are game engines. Again, these are not really clear definitions, but like a game engine is doing a lot of things to sort of process meshes, basically, if you're doing 3D game engines, especially. And then you get a nice, if you're using Unreal Engine, well, Unreal is kind of hard to use, but if you're using a game engine, you get an easier interface where you just sort of make high-level decisions, and then the game engines do most of the work. GPU libraries, right? So AI, yeah. So AI uses a lot of GPUs, And if you're working on a GPU library, you're using a systems level language. CUDA is basically, it's a version of C++, if I'm not mistaken. And then Vulkan and OpenGL are other languages that are low-level systems programming languages. Obviously, compilers and interpreters, debuggers, device drivers, right? So there is still a lot of work to be done writing code for little devices that, go into your washing machine or your car, things like that. Right? So it is a foundation for other software. That's essentially what systems programming is. And one of the ideas behind systems programming is that, well, I mean, hardware is amazing. It really is. I have this computer, I have an expensive computer. It's not that old, but I had to replace it because it doesn't run any of the software anymore, at least at a speed that's like, I just have to sit there and wait for stuff. It's bananas how much better hardware keeps getting. Like and it doesn't seem to be slowing down even with all of these, there was a thermal limit for, anyway, maybe you guys are too young for all this, but there was an idea that at some point it would slow down because of the thermal limit, right? Which is basically the chips are so small that they're generating too much heat and they're going to kind of melt. And basically you get the speed by making things small because everything travels at the speed of light, right? So speed of light's super, super fast, but twice the distance means twice the time, right? So they're packing things as closely as possible, and then they got too hot, but somehow they're still improving things, just being clever, I guess. I don't know. But the whole idea with systems programming is that we don't want to ruin that experience for the applications. We want to use up as few resources as we can so that the applications people can write their slow, bloated code that, clogs up the internet. And for some reason, my file explorer takes 3 seconds to load. But at least, the fault isn't in the systems programming. Hopefully, if we've done our job, then the applications programmers can write their slow code, or, maybe they can write faster code or whatever. Yeah. So the other thing that we're going to be talking a lot to the operating system and making systems calls. Making things like threads and processes and things like that. So the operating system is another thing we're working closely with. Some operating systems, Windows, Mac OS X, Unix, Linux, Android, and Chrome. So services provided by the operating system. So file input, output. Well, I mean, that is kind of low level these days, right? If you're working on a Mac, my wife has an iPad and I downloaded a file and then I tried to open the file and I'm like, where's the file? I don't know where it is. Like it's downloaded. It's apparently somewhere on here, but all that is like abstracted away. My wife can use it, no problem. But I'm like, I grew up with file systems. So that's sort of low level at this point. So file input, output, device input, output, obviously. Process management, virtual memory. Yeah, we'll be asking the operating system for memory. It will give us some, and then we have to carefully keep track of it and then give it back at the right time. And scheduling. So we're going to be looking at threads and how we can lock up resources so we eliminate race conditions and things like that. Okay, so in order to do all this systems programming, we have our set of tools. And one of the things we're going to be using is a shell. So we want to kind of keep this low level because, there are IDEs and they work really well, and you press a button and things compile and they run. And if something goes wrong, then if you don't know what is actually happening behind the scenes, then you're really stuck. So we try to avoid all that. We're going to be going very low tech. We're going to be using shells, command lines. We're going to compile from the command line. We're going to learn a little bit about what's happening behind the scenes. Yeah. On that note, just curious, anybody ever program in assembly? Yeah, really? Do you have like a sort of a homemade thing or just? Oh, is that right? Cool. Yeah, we don't teach that anymore. I kind of want to bring it back, but that's cool. So yeah, because I think it's useful because assembly this class is going to teach you a little bit more about what the hardware is doing. Assembly really teaches you what the hardware is doing. Yeah, so I don't know how I sort of made that jump, but so we're going to be using shells. We're going to be using command line, three major Unix shells, the born shell, the born again shell, and the C shell. I'm not really a shell person. I don't know what the differences are. I don't really think there is a difference as far as we're concerned, but we are going to be using some shell commands. Yeah, we'll talk more about these when we get there. The other thing we're going to be using is text editors. So we write code in text, and then the compiler changes that into machine language that the CPU understands. So some very simple text editors, Vim, Emacs, and gedit. I think we're going to start with gedit. We might actually, at some point, I might go to VS Code. If you want to use VS Code, you're more than welcome to. It is pretty cool. One of the best things that Microsoft has probably done, although it is now getting strangely bloated where it sort of caches a lot of things. So you might notice if you've checked out Brightspace, there are instructions for if suddenly you can't get into your virtual machine. This generally happens if you're using VS Code because we're writing maybe a few kilobytes worth of code, and VS Code is storing 5 gigabytes of cached data. I don't know what on earth they need 5 gigabytes for, but it's there and it fills up the hard drive of your OpenStack and your virtual machine. But then you just go in and delete all those files and it still works exactly the same. And every time I find a solution, then the next semester something else starts caching a bunch of stuff, and it's just this constant game of whack-a-mole that I can't seem to win. So VS Code's great. Just do be aware. At some point, it's going to store enough data to probably crash your virtual machine. Don't worry, it's very fixable. But it's pretty good. But Vim, Emacs, gedit won't do that. There is a steep learning curve for Vim and Emacs, but they are very powerful. Compilers. So our virtual machine is a Linux box. It uses the GNU compiler. The command is GCC. GNU stands for GNU's not Unix. Yeah, I don't know. And so yeah, a compiler computes one language into another, and in this case, it's turning our C into machine language, which is really close to assembly language, right? It's not quite one-to-one, but it's pretty close, and it's so close, in fact, that there are ways to compile C into assembly code so that you can do a more fine-tuned, debugging. We'll look at all that. So the compile command is GCC, and we're going to use a bunch of flags, as you'll see. Do be aware, though, if you compile something on Windows, it will not run on a Linux or Mac, and that applies for all of them. Right? If I compile something on Linux, I can give it to you as an executable. You might have to flip the executable bit, but it'll run. But I can't go between operating systems. I have to recompile. But we can. You can get a GCC compiler and get mostly the same behavior from the same code. Yeah. We'll talk a little bit about that. So technically, you don't have to know what assembly code is for this class, but I do mention it because we are going to start by talking at a really low level what the CPU does, so that you kind of understand what's happening when we compile and run something. But yeah, assembly code is just, C is a real pain to use, and assembly is even a bigger pain, right? Like you're really talking directly to the CPU at that point. We'll see an example of it. Debuggers are another tool. So the GDB, I'm sort of a new convert to this. I am a big fan of print statements. Print statements are lightweight, and they sort of reveal exactly what I want revealed. Debugger is a bit heavier weight. I have to do a bit of more of an investment. But it is pretty cool. So we will do an example of that at some point. Yeah. All right. You do want to get to some programming. So so I'm going to jump around a little bit to start with. So I think we're going to go to a hello world and just do some basic C functionality. And we'll come back to basically this idea of assembly and what your code is actually doing. So I don't know, Igor. I thought this was funny though. He's a Russian programmer, entrepreneur, investor. Done a bunch of stuff, but quality must be enforced, otherwise it won't happen. We programmers must be required to write tests, otherwise we won't do it. I just thought that was a very Russian thing to say. But it's also true, especially for C and C++ and these low-level languages. You'll find there are a lot more things that can go wrong and just kind of quietly go wrong, right? So that they work most of the time, and then all of a sudden something goes wrong. And you have a bug where you never had a bug before. That is really one of the hallmarks of C and C++, as you will see. Okay, so let's make a C program. So what do we do when we make a C program? Well, we write some source code. So we write some instructions in a programming language like C, or in this case, exactly C. And then we're going to compile it. So this will translate the source code into what's called object code or machine code, right? This is not executable on its own if it's an object code. I'll talk about exactly what that means. But it's basically machine language. So when I compile it, I take C. C is very close to assembly anyway. So it compiles it, and then it's something my CPU can understand. And then I can run it, right? And we'll talk about linking as well. But so that's basically the 3 steps, and then 4 if you include linking. But the basic idea is compilation. So yeah. To do that, of course, we're going to have to write code in some. So maybe we'll start with gedit, and then I might try and use Vim. But before we do that, let's look at VirtualBox. So this is what most of you will be running your virtual machine in. It is the easiest way to access the Linux, unless you have a Linux box or you dual boot or something. But if you don't do that, and you have a Windows machine or a Mac that's pre the M1, then this is what you'll be using. So I've already imported this appliance. So this import appliance, if you go to, like if you Google Carleton computer science virtual machines, it'll bring you to a web page where you can download the virtual machine. And the name of it is COMP2401 Fall 23, right? It's the same. Not much has changed since last year, so we're using the same one. Or maybe they forgot to change the name. I'm not sure. So I click start. So after I import it, it'll ask you a bunch of questions. All the default settings should be okay, but there are instructions if something goes wrong. Oh yeah, powering up VM. Okay. But if you have a Windows machine, this is all pretty standard and shouldn't be too hard. Now, what we're going to do is you can write code on the virtual machine, and that will be fine. But what I like to do is use a shared folder. So this means that any files that are stored on my virtual machine are also stored on my host operating system. And if my virtual machine ever gets corrupted, and this happens occasionally, where it's corrupted beyond like what we can repair, then I still have the files, right? They're on my machine. Student, the password is student. And now I'm in an Ubuntu using the XFCE desktop. Okay, so now what do I do? Well, I'm going to show you how to use the shared folder to start with. Hopefully this will, sometimes Zoom will mess this up, but shared folder settings. So I click on devices, shared folder settings, and I'm going to add a shared folder. So folder path, this is I'm going to bring up the File Explorer, and now I choose where on my host machine that I want these files to reside. So what I'm going to do is go into this class, into the code, and yeah, so everything that's in my code folder will now be accessible through my virtual machine, and I'll be able to compile it. I'll sort of have a window with the Linux operating system looking at files on Windows. Mount point, I don't need this. It'll figure that out itself. Auto mount and make permanent if I want to keep it from session to session. Don't make it read only because we do want to write to it. And then yeah, okay. And I go into my shared folder now. I have this SF code, right? Shared folder underscore code, which is the code is the name of the folder on my operating system. I don't know, is that big enough? You guys see? Make that bigger. Well, I have to adjust the fonts, I guess, but yeah. So I have this, and I open it up, and here's all the folders from my the same folders that I see in Windows. If I go to here. Okay, so now when I modify these and I compile them and I can run them, I can do all of those things. But if ever my virtual machine crashes, I still have the code. That's my recommended way of doing it. You can, of course, also just write things to your virtual machine. Okay, so let's open a terminal. So we said we're going to use a shell. All right, so now I'm in this code. I'm going to make a new directory, make directory test, and then ls for list. So I'm going to see all of the stuff that was there before. So these are the class examples from chapter 1, but also this directory that I made, the test directory. So I'm going to move into there so I sort of get away from this other code. And now I want to make a file and edit it. So what I can do is gedit hello world.c. And so this text editor comes up. I love gedit. It's sort of powerful for what it is, just a simple text editor. So now I can write stuff and save it. There's a bit of a problem here. Like I lost, well, I guess I can still type stuff, but it's not interactive anymore, right? I can't type commands anymore. And I'm going to want to compile this stuff. So let's put a little comment here. And then let's close this, and we get back our console. We get back our command line. So now I'm going to do the same command, but in this case, I'm going to do a space and an ampersand. And what that's going to do is it's going to run gedit in the background, but I still have my command line here that I can run commands off of. Like I can still do a list and see hello world.c. So now I have a command line where I can compile things from, and I have my text editor where I can write the code. Okay, so session manager, or do I? Okay, that's fine. It might complain every time I try and save, I guess, or do something. Okay, so let's write hello world. To write hello world, could not save. Okay. See, that's the beauty of a shared folder, right? Is that if I run into this problem, there is a solution. I ran into this problem before, actually. Why is it not working now? That's weird. Okay. So that didn't work, but let's try something else. We can try Vim, or the beauty of a shared folder is I can do something like this. I can go in here to the test folder. Hello world, I can open it with, I guess, Visual Studio Code. All right, let's just do Visual Studio Code. Okay, so now I have a text editor in Windows, and I have GitHub Copilot running, right? This is a large language model. So you can see I use it. It is very handy. We'll explain exactly the situations where it comes in handy and the situations where I have to turn it off. So we're going to turn it off here. But now I can do include standard input output. So we need the standard input output in order to be able to write stuff to the console. And now if I go into my virtual machine, and now here's another command. What did I call it? Hello world. Yes. So if I say cat hello world.c, it just takes everything and spits it out to the console. And you can see that the changes that I made in my host environment are now reflected in my virtual machine. Okay, so everything, all the files kind of exist in both of these places. And then I can do, yeah, I guess we might as well continue with this version of it. So my hello world, everything in C starts from the main function. The main function returns an int. I think you can also do a void, but I'm gonna have to test that out. I mostly teach C++. In C++, you can do a lot of stuff that you can't necessarily do in C. I might confuse these two things. But printf, so print formatted is the command. And then I'm going to write hello world and a semicolon. Okay, so this is a program that should be able to run. And just for completeness, if I don't do this, everything will be fine, but I'm going to return 0. This means that I finished without any problems. No error code. If I return 1, that's an error code. Okay, so let's compile this and run. So how do I compile? I use the gcc command, and then I put the file. And then let's see, we've created this file called a.out. Okay, so let's, all right, and this is what's called an executable. So I took the code that I wrote here and I compiled it and it turned it into a version of this that the CPU can understand. Okay, so now I want to run it. Now, when I do stuff like ls, that is also a program. It's just a binary file that gets run, the same as this a.out file. But when I write a command, what the shell does is it has what's called an environment variable called path. And path just is a file path to a bunch of different folders. And these folders have executables in them, which are the commands that you have access to. The one place it doesn't check is the current directory. Right? So I have to tell it to look in the current directory for this. If I say a.out, command not found. So I have to say, well, look in the current directory, which is the dot. And then this is the file separator, and then a.out. And that means run this executable. And I get hello world back. Okay. All right. Question so far? Yes. That happens automatically. Why a.out? I would have to look that up. But we're going to fix that in a second. Yeah. Yeah. No. If you have something like Dropbox running, like that updates it, or you use GitHub, or like, almost everything in all, or OneDrive. So if you have something that will update that file between your two computers, then you can just have a version of the virtual machine on both, right? That will work. Yeah. Yeah, perfect. Yeah, that's actually what I do. It's because I'm too lazy to use Git, but yeah, Dropbox works pretty well. Other questions? Okay. So yeah, this a.out is pretty ugly. So what we're going to do is we're going to add a flag -o So this means to output. And then I'm going to say, let's see, hello world. Okay, so that's my output file, and then hello world.c. And now if I list, I can see that I have another file here called hello world, and this is also an executable. And if I do this, I get hello world back. So one thing that might happen, this is, let's try. Maybe I forget to actually put the output file and I do this. No input files, compilation terminated. You have to be very careful because, well, there are instances where maybe I am compiling a couple of files. So I put two of them, but I forget to put an output file. And what it's going to do is it's going to overwrite this as an executable, right? So there's a lot of things in Linux and C in the command line that's very unforgiving, and that's one of them. The other is, as you will see, so I have this other command, this a.out, I want to get rid of it. Okay, so very simple, rm for remove, a.out. And yeah, now a.out is gone like forever. Okay, so if you use rm, be very careful. Don't remove your source code because there's no getting it back. Like really, there's, yeah. Cat. Oh, cat? Yeah, so that is, the history of this stuff is so bananas, like where they get these names, but cats is short for concatenate, which takes two files and concatenates them. But basically what this does is, if I don't specify, it takes the file as input and then it outputs it to the console. So all it's going to do is read a text file and print it out. That's what it does, essentially. If I try to do that to, well, that's interesting. Yeah. See, there are some stuff here that is sort of human readable, probably the comments or metadata about the file, but then this stuff here is basically machine language. Yeah, so concat stands for concatenate, which I always found the naming of these Unix variables is the worst. Like I could never just by looking at a thing know what it does instinctively because it's always named something weird. But once you get used to it, it's pretty easy. Other questions? Yeah. It's an executable. So let's talk about object code. Yeah, because I haven't made any object code. Even though object code is technically basically the same as an executable, except for like one bit is flipped. That is true if I have a single object file. So I want to make some object code. I'm going to compile just the same as before. Instead of -o, I put -c and hello world.c. Now, if I look at this, now I have a hello world.o. And what is this? This is machine language. It's called object code, but it's machine language that basically can't be run. Right? So if I try to run hello world.o, yeah, cannot execute binary file. There's some sort of formatting error. But it's basically exactly what's in here, actually. Maybe not exactly. So yeah, there's a bunch of, but this is the same set of instructions that you would find in this file. But basically, I haven't told it that it can execute itself. So why do we make an object file? It's just basically an intermediate file, and then I can say -o, hello world. And as input now, I'm going to use the object file instead of the source code. And then when I run hello world, all right, I get the same thing. So why do we have this intermediate step? So when we write bigger programs, we're going to have multiple files. And what we want to do is sort of compile each file individually. Now, it doesn't matter for our little tiny programs because everything is going to compile blazing fast. But when you get to bigger code, you want to compile these files separately because compiling actually takes a long, long time. on a big code base. So if I make changes to one file, I don't want to have to recompile everything. I just want to recompile the files that I need. And then if I do that, this linking step is very fast because all it's basically doing is everything's precompiled, but now I'm just pointing, when I call this function, oh, here's the code for that function. That's all the linker's doing. It's filling in memory addresses. So yeah, this is sort of, yeah, we will focus on that a little more when we get to multiple files. That is basically how we'll be doing things. We'll be pre-compiling and linking them. But for now, really just the regular compilation where we do, right, yeah, this one is fine for our purposes right now. So this is all you need to compile your own program and run it. Right. Other questions? Yeah.
About the image, like what's the difference between this image and just a regular bunch image?
Image or like just like a probably nothing. So yeah. So that's the other thing is that if you have a Linux machine and you are running Ubuntu 22.04 or even 20.04 or 18.04 or whatever, it's probably going to be fine, right? Like there's really, we are working at such a low level that that part of it almost never changes, at least not within, the timelines that we care about. So yeah, feel free to experiment with other versions. If we run it against Gradescope uses exactly, I believe, like if I go GCC version, oops. So the version of this GCC is 11.4.0. But last semester we were using 11.3 and probably before that 11.2, and it's all the same stuff, right? It's going to work. I would be incredibly surprised if there's any difference at the level that we're working at. So yeah, feel free to experiment with a different setup. Just, try and make sure you're running GCC and something close to this version, and you're probably going to be okay. Other questions? Yeah. Well, let's see. I don't know. I can't remember if I installed I may have installed GCC on this version of Windows. So let's try it. Let's go. Oh yeah. By default, I do not think there's a GCC compiler in Windows. Fatal error. So I do have a gcc.exe, and most likely that will compile. It'll give me something that I won't be able to run. All right, don't do that. It's the one thing I hate about autocomplete is when it's trying to be helpful and it's like anything but. Oh yeah, output. Let's just make it hello. This is a lot slower, right? And then I should be able to run this hello world. So yeah, now I have it running on Windows. If I go back here if I try to run hello, whoops. Oh, hello.exe it is. Okay, so let's try that. Yeah. So it compiles differently. The languages are different between Linux and Windows. But yeah, so I do have a GCC compiler and for our purposes, it's probably okay, but I haven't tested everything. Yeah. It's the compiler, so it's the GNU compiler. If you want to install it on Windows, the easiest way that I find is it's a program called Code Blocks that will install it for you. It's its own IDE. But if you go to the GNU website, it may give you some options that you can use. Okay, so let's yeah, other questions? Yeah.
shared folder setting that you did?
How I got there or what?
Set it up?
Yeah, yeah. So you go to devices, and shared folders, shared folder settings. And then from here, I can access all my shared folders and delete them or whatever. So I'm going to add one. Now, the most important part is the folder path. This is which folder that I'm sharing. So let's see, if I go to assignments, where can I go without giving it too much away? Well, let's just go to this. Okay, so mount point. So if I don't like SF_CH1, I think I can just say what it's going to be called. Although I've never actually used this. Let's try it. Chapter 1, and then auto mount and make permanent. So I make it permanent. So if I don't auto mount, when I boot into my virtual machine, it's not going to be mounted, which means that you won't have access to it until you mount it, which means basically it's going to give it a memory location so that you can read from it. So I wanted it to auto mount. So when I boot into my virtual machine, it's ready to go, and make permanent so that it's persistent. You know, if I don't do this, then it'll be erased, I think, the next time. Yeah, let's auto mount. Okay, yeah. So is that all right? So if I go into my shared folder now, you can see, well, no. Oh, so yeah, sorry, the mount point is not what I thought it was. I haven't actually used it, but so what it means is if I start looking through my Linux file system, I have to look now for a folder called whatever I called it, chapter 1. But it's also going to be linked in your shared folders directory. So yeah, the mount point is really, it doesn't matter. You're still going to have access to it here. And yeah, here's a bunch of code from my machine. All right, good. Other questions? Okay, is there anything I promised to talk about that I've forgotten? Perhaps. Let's look at, let's say Thursday. Yeah, this is the last time I'm going to see you, right? So here's the, so again, the tutorials are not live, but I'm going to show you where you would go to find them. I do have to do a little bit of editing. Incidentally, anybody know what language this is? What's that? This is not assembly, no. I'll show you assembly. Actually, I can show you assembly. It's pretty cryptic. If I go GCC-S hello world.c, and then I get this hello world.s. And if I look at that, oh, I don't have a folder. Okay, so I'm just going to cat. All right, so this is sort of what assembly looks like. And we're gonna, like, almost nobody knows how to program in this anymore. And a little bit of basics about what exactly is happening. Some people can read it. It's important if you work in these languages, you can read it, but almost nobody tweaks this code anymore. But it used to be almost exclusively what we did. Yeah, this is actually BASIC, but it's an old version of BASIC from, well, I used this exact stuff on a Commodore 64. So yeah, we had line numbers and then for loops, and we had go-to statements and prints, and anyway. So tutorials, you'll go here, you click on this. I'm going to click preview. It's not currently visible. I'm going to bypass the restrictions. Again, there's some, I have to do there's some formatting problems. But what you're going to see is, so this should take you about 80 minutes, and then you just answer the questions based on, you follow the instructions. It's going to say, please do these commands and or write this code or modify this code. And then it's going to ask you questions based on those things. And then you just answer them. Yeah. Yes, it'll be out by Monday, yeah. So now, it says 80 minutes. So here's what's going to happen. So a TA is going to be assigned to go through everybody's submission. And if it took you 5 minutes, you get 0. Okay, so it should take you 80 minutes. That's how it works. That being said, I don't mind if you like work in groups, right? That's okay. You're still learning, you're sharing knowledge, nobody's getting stuck. You can help each other out. As long as the time is something reasonable, right? If it's completely unreasonable, again, this is obviously, there are multiple ways to cheat doing this. If you make it obvious, you're going to get 0. That's all. But yeah, so that's the idea behind these things. For now, at least, this is what we're going with. Right. So here he asks you to do the remove command, type in date. So this is going to get you familiar with some of these commands that I've been using. But I hired my son to put this in, and I think he didn't really, some of this formatting leaves something to be desired. So I'm going to go through and fix it before I release it. Okay, questions on that? Yeah. I'm sorry? Oh, it's 80 minutes, it's approximate. Like if you do it in 45, you'll get the marsh, right? Like it's just if you're completely, if it's 5 minutes, then I know you've cheated, right? There's no way to do it in 5 minutes. Yeah. No, you should be able to do it across a few days, and it'll track all of all of your sessions together. Yeah. So yeah, no worries. You can do a little bit here and there, and in fact, that's probably the best way to do it. Yeah, in this case, I'm not sure there is any code in the first one. There, yeah, you'll be running your VirtualBox, and then there's a little bit of code here. So you'll be running VirtualBox and then entering these commands as per the instructions, and then just you'll get some output, and you just answer the multiple choice. All right, good. Yeah. No, yeah, you can take as long as you want. Yeah. So yeah, we're worried about too short, not too long. Yeah. I think, but they'll be due in like a week, right? Just there's got to be some deadline on it. Yeah. Yeah, I'm not, maybe I didn't hear everything correctly, but this will just give you a mark based on these multiple choice, right? So this is really weird. I don't know where my son got part of it, but let's say, yeah. So let's say I make a directory called temp. Oops. Tempt. All right, sure. So you can see here I have a directory called tempt, and if I follow the instructions for this now, and I use the remove command on the directory. So, whoops. So I'm going to say remove tempt, and it says cannot remove tempt is a directory, right? So then I go back here, and that is one of the options. Say cannot remove test directory is a directory. So I would click that, and then that's it. And then the next one, it says type in date and see what happens. So I would go date, and this is the date. And so that corresponds to, yeah, you select which format, right? It doesn't have to be exactly the same date. So that's it. It's going to take you through a few commands that are going to help you sort of navigate these new environments, and then eventually it gets to some coding as well. But I have to clean it up before I release it. All right, other questions? Yeah. The tutorial sessions? No, don't have to. Also, what is there? 2 sections? Attend whatever one you want. Yeah. Yeah. Basically 20 minutes or so after class, it should be ready. It takes a little while for YouTube to process it. It's private on YouTube, right? So don't worry about your information. I could change to the school system, but over the pandemic, I got used to YouTube because it was reliable, right? It never goes down. But it's private. So if you have the link, you can access it and nobody else is publicly going to see this. Yeah. You can start reading. If you want readings, I can make you readings. Yeah. Yeah, I mean, it's pretty much, I do follow his notes pretty closely. They're very good. I like them. Other questions? Okay, so yeah, that's it for today. I'll see you guys next week. And so watch out for the first tutorial will be released, and also the assignment should be released before Monday.